Hi everyone, this is our first lecture on probability. We will have an introduction to the concept of probability. We'll go through a series of examples and we will also end with an exercise. Why do we care about probability? The short answer is the world is not always predictable, especially the business world. Many events cannot be predicted with total certainty. The best thing we can say is how likely things are going to happen. For example, is it going to rain or not? That seemed to be a yes-no question, but the answer usually cannot be simply put in yes or no format. Instead, we'll say that the likelihood to rain is 70%, 80%, 20%, or 0%. If you're pregnant, is it going to be a baby girl or a baby boy? We will always like to guess, but we don't always know for certain. So we can only say, is it likely to be a girl or a boy? Is she going to marry me? Is that a yes-no question or a probability question? I've lived in Pittsburgh for a long time, so the most important probability question we have in Pittsburgh is always, is the Steelers going to win the Super Bowl or not? As a manager or an investor, a very important probability question for you is whether the stock market is going to go up or down. Again, you will see that up or down seem to frame the question as a yes-no question, but usually the answer we get is a probability answer. It's probably going to go up, it's probably going to go down, it's likely to go up, it's unlikely to go down. If you're a product manager or brand manager, you will care a lot about whether the customer is going to buy our products or not. Again, this seems to be a yes-no question, but the answer is usually stated in probability terms, right? Very likely, somewhat likely, unlikely. Let's look at an example. Say you work for the company Hershey, which manufactures many different kinds of chocolates. Let's say that you're in charge of determining demand for Reese's peanut butter cups in a new market. How would you know the size of the new market? Well, you can use probability to answer this question. So what is probability? Probability measures how likely something is going to happen. It's a number. So this is really a way for us to quantify this concept using a number that varies between 0 and 1. 0 is the number that indicates total impossibility. That means there's no chance that this thing is going to happen. 100% or 1 indicates 100% certainty. The value of probability cannot be greater than 1, and it cannot be negative. You will often see probability as represented as a pie chart. And it's almost like a pizza pie. And if you get all of it, it's 100%. So one pizza is 100%, or the probability of 1. Here's just a little silly thing that, a silly shirt that you can actually buy. So the shirt says there are two types of people in this world. Those who can extrapolate from incomplete data and then blank. And over here, so two of my classmates just asked our professor if his shirt is missing a second part. So what does that mean? Well, you find out pretty soon, but basically because the pie is always 100%, so if you only have two types, the first type is those who can extrapolate. So the second type has to be those who cannot. So there's the probability of an event, the probability of the negative an event, which we'll see pretty soon. Everything will add up to a single pi. So what's a probability event? Flipping a coin is a very classic example. If you have taken statistics before, you will often see the coin flip example. So the question is, before you flip a coin, you can always guess, am I going to get a head or a tail? Even though this is such a common task, you actually never actually know what the outcome is. You cannot predict it with 100% certainty. The only thing you can say is the probability of getting head or probability of getting tail. In other words, the outcome of flipping a coin is uncertain, and therefore this is a probability event. Usually we call these random events, meaning that what the outcome will happen will be completely random, especially if the coin is fair. Flipping a coin is a random event of an experiment. So each time we flip a coin, in statistic terms, we are conducting an experiment that has an uncertain outcome. We don't actually know what's going to happen. We can only predict the probability of it. We know that there are only two possible outcomes, heads or tails. And we know that if we flip this coin many times, we will on average get heads 50% of the time and tails 50% of the time. But even if we know this, even if we have done this many, many, many times, and we know on average, heads is 50% of the time, tails 50% of the time, before I flip the coin again, I still don't know what's going to happen. So that's the sort of the randomness of it. And hopefully you can see that this is actually no different from predicting if someone's going to have a boy or girl. Because on average, we know from years and years of experience and data that you get a girl 50% of the time, you get a boy 50% of the time. But every pregnancy is different. Every new pregnancy is a new random event. So even with that knowledge of historical statistics, we still don't know if we're going to get a girl or a boy. We only know the probability of getting a girl and the probability of getting a boy. So this is how we express the probability in numbers. So we will say that half of the time we will get a head, half of the time we'll get the tail if we have a fair coin. So 1 over 2, that fraction means 50%. Sometimes it's expressed as 0.5. So you will see these three different numeric expressions. 1 over 2, 0.5, or 50%. They all mean the same thing. It just means 50% of the pie. Because the probability of all the possible outcomes, so there are two possible outcomes here, head and tail. The total probability for both events is 100%. So everything has to add up to 1 or 100%. In a fair coin scenario, the probability of either event is 50%. Now, what if you have a dice? What's the probability of getting 1, 2, 3, 4, 5, or 6? If you have a fair dice, the probability of any of these 6 events will be 1 divided by 6. Because again, the probability of all these different events will add up to 1. And because it's fair, so the probability of getting any given event is the same. So what we do is we take the pi of 1 or 100% and we divide it by 6 pieces. And so the probability for each one of them will be 1 over 6. And they should add up to 1 or 100%. You can also express the probability in decimal values, so 0.167, 0.167 all the way, and they will also add up to 1. Another way to express the probability of 1 over 6 is using percentage. So 16.7% is the probability for each of these events. And again, they should add up to 1. In scientific notations, we will formally write the probability of an event as P square bracket, the name of the event. So if we use abstraction, we represent an event, any given event, as X, then we can just say, well, the probability of X is P square bracket X. Okay, so X can be anything. Over here, if we are flipping a coin, we have two possible events. So the head event and the tail event. So what you do is you can just replace X with head and write P square bracket head. Okay, to represent the probability of head. Okay, we can also do P square bracket tail to represent the probability of getting tail. Okay, so in a lot of the formula expressions, textbooks, you will see this notation quite often. Similarly, you will also see P of Y, the probability of the event Y. In this particular case, we could say, well, there are 6 events, right? 1, 2, 3, 4, 5, 6. And so Y, the event Y is just an abstract representation of any event, just like X. And in this particular case, we can say, well, Y is the event of getting 1. And so we can use P of 1 to represent the probability of the event of getting 1. P of 2 to represent the event that we get a 2. And so on and so forth. Again, the numbers should always add up to 1. Let's take a look at how these values can actually be represented on an Excel spreadsheet. I'm going to use Google Sheets for this class because Google Sheets are hosted in the cloud, so we can all access the same file simultaneously online. You can click this link and it'll take you to the website. We will be using this Google Sheet for all of our class exercises. You will see there all the upcoming sheets from when we have the class. These will be going through each of these tabs. So there are many different tabs. I want you to pay attention to this first one. It's called S1 Prob, or Summer Lecture 1 Probability. Okay, so this is an example of how we will represent these numbers in a spreadsheet. So we have dice, throwing a dice and getting 1, getting 2, all the way to 6. Each one of them is 1/6 of the probability. So you can actually express the equation as you could type equal 1 divided by 6. Okay, so this formula will actually give you this value. And you will see the values vary slightly from the slide because of truncation. It really depends on how many decimal values you want. And on the slide, I only use 2, so you can actually decrease the number of decimal values using this button. So this, I think, corresponds to this, the PowerPoint slide. Because on this spreadsheet, I can represent a few more decimal values, so I'm just going to increase it. You can see that this is a total. It's a sum of all of these. You can see the orange color indicates the range of sales. That's part of this equation, sum, parentheses, parentheses, and we have the sale addresses over here. So this is just the total is the sum of these 6 values. And you can see that this number updates dynamically as I change these values, okay? This equation will update to represent the current total of these 6 values. Okay, so you can see that this is how we can easily translate the concepts that we just talked about in class to an Excel spreadsheet kind of exercise. I want you to start getting used to this translation. We'll be doing this a lot in class. You can also take these numbers and represent them as a pie chart. So this is the pie chart that represents these 6 values, right? So dice 1, dice 2, all the way to dice 6. Now, how do you create a chart like this? First of all, you want to select the range of numbers. Actually, we want to select the labels as well if you want the labels to show up on the chart. What I can do is I can select this range and then I can do insert, chart. Google Sheet will automatically recommend a chart type, and the default is column chart, but I'm going to switch to a pie chart. So either one is fine. You just have to select the one that you want to have. Right now, by default, the columns are used as the columns or the rows are used as the values in the pie, but our data is represented this horizontal way. So what I want to do is click switch rows and columns, and then this is how we get the pie. If you want these values to show up, you go to customize, pie chart, and then change the slice label to value. And there we go. So this is how you would create a pie chart out of your probability values. You see a lot of pie charts in my PowerPoint presentation, so I want you to see that you can actually do this on your own by hand. Hopefully that will help you get a deeper appreciation of how a pie chart is constructed and why we see pie charts all the time. All right, so I am going to delete this. That way we will just have one chart here. Okay, let's go back to our PowerPoint presentation. Now, here is a little quiz for you. I want you to look at these probabilities and tell me if any of these values is possible. So is it possible the probability that the stock market will crash is negative 0.7? The probability of me getting a bonus for the year is 25. And the probability of buying my dream house is 0.28. Think about this for a moment and see if you can figure out why only the third one is a valid probability. The other two, this one is good. The other two are really invalid numbers. These are wrong. These are not possible probability values because probability has to be between 0 and 1. And so it's not possible to have a negative value. Okay, so this is a negative value, and it's not possible to have a value that's greater than 1. This one is greater than 1, so those two are both impossible numbers. Let's quickly go over some basic terminologies. You will often hear a set. That's basically a collection of elements. An element is just an occurrence of an event. It's a single member of a set. and the subset is any part of a set. So let's take a look at an example that illustrates set, element, and subset. So let's say we have a 10 by 10 grid that represents 100 elements. Each one of the cells is an element or an event. It could be a person, it could be a customer, okay? And let's say that this chunk of people, let's say we have 100 customers, and we have this chunk of people, we have surveyed our customers, and we know that this chunk of people like chocolate. So it's a grid of, let's say, 1, 2, 3, 4, 5, 6. So 6 down this row, the rows, and then we have 4 across. So this is 6 times 4, or 24 people out of 100 who actually like chocolate. And then we also have a chunk of people who like peanuts. Okay, so this is another set of people who like peanuts. And this is 4. This is also 4. So this will be 4 times 4, or 16 for peanuts. And you will see that those who like chocolate, some of them also like peanuts. So this is an area where the two probabilities actually overlap. So you can see that we can easily divide our customer base into several different types. Those who like chocolate, but not peanuts. Those who like peanuts, but not chocolate. And those who like both peanuts and chocolate. We also have this outside area, okay, that indicates customers who do not like either. They don't like chocolate, they don't like peanuts. So what we will call is, this is a set of 10 by 10 or 100 elements. So each one of these cells is an element, and we have a set, which is the total population, or the area, or the possible events that we are looking at. Each one of these cells is an element, and we're looking at 100 elements. This is called a subset, right? So this is the portion of 6 times 4, or 24, is the subset of people who actually like chocolate. And then, of course, we also have a subset for those who like peanuts as well. We talked about how the experiment is a process with unknown outcome. So when we go back to the set, this grid, an experiment is really just the activity of picking someone at random. So if I want to just randomly pick one of the cells out of this grid, how likely is this person going to like chocolate? So that would be my experiment. You will also often hear sample space, event, and probability. So let's go over these as well. So the sample space is a set of all possible outcomes for an event. Okay, so here, liking chocolate is an event. Liking peanut is a different event. So let's just focus on one event for now. So the event here is whether someone likes chocolate or not. And the sampling space is a set of all the possible outcomes. Okay, so the sampling space is the entire set over here. And the probability of liking chocolate, like we talked about, is 24 out of 100, or 24%. So we will represent the event C as like chocolate, and the probability of liking chocolate will denote that as P of C. And because we know there are 24 people out of 100 who like chocolate, the probability of finding a customer who likes chocolate is 24 divided by 100, or 0.24. The sample space includes this possible outcome, which is someone likes chocolate, but it also includes this other outcome, which is somebody may not like the chocolate. So we have the outcome of C and the outcome of not C. Okay, not C is the rest of it, right? So the rest of the set over here is called not C, and not C will be 1 minus 2.24 or 0.76. Likewise, there's a sampling space for the event of liking peanuts. And the event of liking peanuts has two possible outcomes. You may like the peanut or you may not like the peanut. So the event we call the event of liking peanuts, event P. And we denote the probability as P of P. And we know it's 16 people who like peanuts. So the probability is 16 divided by 100 or 0.16. So that's this subset over here. Out of these entire sampling space, which is the whole thing, we have 16% of them who will get the outcome of P, and the rest of it is not P, which is 1 minus 0.16 or 0.84. Okay. So, a couple of sort of properties of probability. We have seen a lot of known probabilities, things that we have known for decades and, hundreds, if not thousands of years. We know that when we have a fair coin, the heads versus tail probabilities will be 50-50. That's a known probability. So with many, many, many years of experiments, we already know this pretty well. Also, if we have a fair dice, we know the probability of getting any of the 6 events is 1/6. So we've known that pretty well. We actually have engineered or designed the dice to be that way. So in a sense, we have manufactured these probabilities. Also, with years of wisdom and experience, we know that the probability of getting a girl versus a boy is 50-50 as well. So I would consider these as known probabilities. However, life is also full of unknown probabilities. Very few things actually come with known probabilities. In fact, in business, managers deal with unknown probabilities all the time. So for example, are people going to like my new product? Is Liam going to like this movie on Netflix? Am I going to recommend this movie to Liam or not? I don't know. I have to actually figure out the probability. Is the stock market going to go up or down? Is Jim going to leave the company? Is Trump going to win the election? Is Lisa going to marry me? These are all questions with unknown probabilities that a lot of times we have to collect some empirical data to figure out what the probabilities are. Nobody hands us the answer key. You as a manager or you as a decision maker has to actually figure out the probability. And so hopefully you can see that as a manager, a professional, a decision maker, oftentimes has to be in the business of estimating probabilities for business decisions. And again, this is because business decisions involve a lot of uncertainties. Managers manage uncertainties by estimating probability of events. And the managers can then make predictions using these probabilities. Probability is not always known. Many probabilities for business events are unknown, so you will have to estimate these probabilities. So to recap, we have introduced a lot of new terminologies. So make sure that you're comfortable with these definitions of set, element, subset, experiment, sample space, event, and probability. And now we're going to end this lecture with an exercise that I would like you to complete in Google Sheet. So go back to the Google Sheet file that we look at. I want you to observe the dice probability example that we just went over on S1 Prob, that tab. And then I want you to think about the like chocolate versus like peanuts example. And I want you to set up the probabilities of these two events in a new sheet. Now, you can't edit the class Google Sheets file because it's only for view. In order to edit anything or create things on your own, you will have to set up your own Google Sheets. You could do this in Excel. You can do it in Google Sheet. It doesn't really matter. You can simply copy. You can make a copy of the class Google Sheets and make a copy into your own Google account. You can also just copy and paste or download the Google Sheet file as an Excel spreadsheet. So what I want you to do is to think about how you would set up the probabilities of liking chocolate, do not like chocolate, liking peanuts, not liking peanuts, how you would set up these probabilities in an Excel format, and how would you like to chart them, right, as pie charts. So try to do this on your own, and then there's an answer key that is on a hidden sheet called S1 Prob Key. So it's hidden, which means that when you go there, you're not going to be able to see it. However, so you don't see S1 Prob Key sheet when you come to Google Sheets. However, if you go here, you will see S1 Prob Key on the list of tabs. This one is sort of grayed out, so that means it's hidden, but if you click on it, this will come up. Okay, so I'm going to hide it now, and I'll let you think about this. Struggle with this, try to do this on your own for a few minutes before you look at the solution. Good luck, and if you have questions, please feel free to let me know.